Hello everyone. In this video, we are going to look at the concept called unit from the chapter Units and Dimensions. Before describing what is unit, let's try to understand what is a physical quantity. Now we all know that we have been hearing this word physical quantity from a long time, but many of us doesn't actually know what is a physical quantity. So let me take an example. So I take an example of a table. Is table a physical quantity? Many of us would say yes, but then table is not a physical quantity. Now why table is not a physical quantity? Because in physics, only those quantities which can be measured are taken as physical quantities. So table is not a physical quantity. Mass of table is measurable, so that is physical quantity. Similarly, let's say height of table is a physical quantity, density of a table is physical quantity. For that example, like, is a human, am I a physical quantity? Again, I am not a physical quantity, but my mass is physical quantity, my height is physical quantity, whatever you can measure, that's physical quantity. Now let's see how do we define. A physical quantity or quantities which are used to describe the laws of physics are called physical quantities. So, and these physical quantities are again classified into two categories, that are fundamental quantities and derived quantities. Now let's look at what is a fundamental quantity. Any quantity which form the basis to define other quantities are called fundamental quantities. What do I mean by that? Let's say I want to define density. Density is what? Mass per volume. What is volume? Volume is length into breadth into height. So we are saying that density depends on mass and volume. Volume depends on length or breadth or height or the dimensions of the object. But what factors does mass depend on? Now mass doesn't depend on anything, but density depends on mass. Similarly, length doesn't depend on anything. Volume depends on length. Again, because volume depends on length, density depends on length. So here mass and length are what? Fundamental quantities. Now let's see how do we define them. A set of minimum number of quantities required to give a consistent and unambiguous description of all other quantities of physics are fundamental quantities. I hope you're getting it. So they should be unambiguous, there should be no confusion about it, and they should be in a position to define all physical quantities that are there. Now these fundamental quantities should be independent of each other. So that's what I said, because they're fundamental, they should be independent of each other. Length and mass should be independent of each other. In SI, there are 7 fundamental quantities. So in standardly, we have 7 fundamental quantities. These are mass, length, time, temperature, luminous intensity, electric current, and number of particles or amount of substance. So that means what? The whole physics or all the quantities that are existing in physics can be defined in terms of these 7 quantities. That is why these 7 quantities are known as fundamental quantities. After that, we have derived quantities. What are derived quantities? These quantities are defined in terms of fundamental quantities. So quantities which are defined in terms of fundamental quantities are derived quantities. We just saw the example like density. Density is mass per volume. So density is a derived quantity. Volume is, if I take it as a cube, a cube. So volume is a derived quantity. So what are derived quantities? Quantities which are derived from fundamental quantities or which are expressed in terms of fundamental quantities are derived quantities. Velocity, length by time, derived quantity. Force, mass into acceleration, derived quantity. Momentum, mass into velocity, again derived quantity. So any quantity which is expressed in terms of fundamental quantities are known as derived quantities. Then we have a third category of quantities. Those are supplementary quantities. What are these supplementary quantities? The quantities which cannot be exclusively classified into derived or fundamental quantities are known as supplementary quantities. I hope you're getting it. So then they cannot be classified as either derived quantities or fundamental quantities. I'll take an example. In fact, there are only 2 derived supplementary quantities. The example is, I'll take the example of angle, a plane angle. Like if I take a plane angle, So let's say this is a circular loop, there is an angle theta. Now angle, when I say it is an angle, it seems to be, what angle? It seems to be fundamental quantity. Why it seems to be fundamental quantity? Because we see that nothing, nothing is based on this. But then if I define 1 radian, how do we define 1 radian? Let's say r. 1 radian is the angle subtended by an arc whose length is equal to radius. So in that case, what is theta equal to? Theta equal to L by r. Now here I see that 1 radian is depending on the length. So here it appears to be derived quantity. So because it cannot be exclusively categorized as derived quantity or fundamental quantity, this is called supplementary quantity. Now let's understand what is a unit. Whenever we want to make a measurement, what we do, we express it in some units. And during the process of expressing, we're doing something which generally we are not very conscious of. Something like when I say 50 kilograms, I mean to say it is 50 times 1 kilogram. That means 1 kilogram is repeating itself 50 times to give that particular physical quantity. Similarly, 3 meters. That means 1 meter is repeating itself 3 times. So, what is happening? So what are we doing? We are trying to compare our physical quantity with a reference. The reference can be 1 meter or 1 kilogram or something else. So how do we define? So that reference is called a unit. So how do we define a unit? Let's see the definition. To measure a physical quantity, we need to compare it with some reference standard. That reference standard is called a unit. So that's what is the basic definition of a unit. Now sometimes what happens is when we don't have anything handy, we find our own units. A very common thing when when people go to play cricket in the ground and they don't have the pitch, what they do, how do they mark that pitch? One of the person starts walking from one side and counts 22 steps. So that distance is not exactly 22 yards, it is 22 steps, where one step is a unit. Now if some other person comes, his step might be longer or shorter, so that 22 steps would be different. Of course, the error might not be very high, that's why we take it for granted, but that's not a standard unit because it's not same everywhere. So that's why we define some characteristics of a unit so that that unit is internationally accepted. The characteristics are, it should be well defined. So it should have a proper definition that 1 meter is this much, 1 second is this much. Now it should be easily reproducible. Now what do we mean by reproducible? Like 1 meter in India should be easily be reproducible in some other country of the world. So then 1 meter can be taken as an international unit. It should be imperishable. It shouldn't be something like, today it is there, tomorrow it is not there. So it should be eternal. It should be convenient in size. Like I want to measure, let's say length of the road. I can't take a meter stick and measure it. So I have kilometers as a unit there. So if I want to measure, our clothes, then meter is a proper unit. So we should have a proper convenient unit size should be proper. Now it should be accessible. Now it should not be like only a few people in the world can access it. It should be easily accessible for everyone. So if all these characters are fulfilled, then that particular unit is internationally accepted. Now there are 7 fundamental quantities. We have seen that. So these fundamental quantities have their units, and these units are called fundamental units. So for length, the unit is meter and the symbol is small m. Similarly for mass, the unit is kilogram and we represent it by kg. Time, the standard unit is second, so we represent it by s. Luminous intensity, again the unit is candela, which is represented by CD. Temperature, Kelvin is the unit. Electric current, ampere is the unit, and number of particles or amount of substance is mole. So these are the 7 fundamental units of the 7 fundamental quantities. Then supplementary units. So the quantities which are supplementary, the units of those quantities are called supplementary units. Now we have only 2 supplementary quantities, that are solid angle and plane angle. Plane angle unit is radian and solid angle unit is steradian. Similarly, derived quantities units are called derived units. Like here the example, it says Newton. Newton is what? Mass into acceleration. Mass unit is kg and acceleration is meter per second square. So kg meter per second square is Newton. So in that way we have taken example of Newton. I mean force, you can take energy, anything. So all these derived quantities have units. These units are called derived units. Hope you could understand everything. Thank you for watching for this video. Thank you very much.